All right, I'm Scott Tashakkor, and I'm from the Marshall Space Flight Center, and I work in the flight software division out there, so we do all sorts of stuff. I'm going to be talking about the automation of our software regression testing today. And for those of you that use UT Assert on CFS, you'll notice a lot of similarities. I was noticing that yesterday. So just to give you an overview of what I'm going to talk about, I'm going to kind of introduce you to everything and kind of the situation, tell you what the requirements were that we ended up having to fulfill, give you kind of how the test harness set up using its modularity, how we put in inputs, how we compare our outputs, and then when we run the test cases, and in the end kind of give you some conclusions and how well it's worked. All right, to introduce it, this has been developed during the Space Launch Systems flight software development. SLS, for those of you that don't know, is a man-rated heavy launch vehicle. It is being developed at NASA with a lot of outside contractors helping to provide hardware and other resources. The flight software for the vehicle is being developed in-house at Marshall, and so we have Boeing flight computers that we are actually writing the software for. Boeing gives us the drivers and everything, so we're not at that layer. Flight software, we provide all the computer functions, so we're doing all the communications, telemetry, control of the vehicle, and everything to that. And at Marshall, we're using an incremental agile software development. Agile is in quotation marks here because we've deviated from I guess the standard is what you want to say, but I'm not going to talk about that. There's actually another person here from Marshall that is going to address a little bit more of that tomorrow. I don't remember what time. But it was to try and it was to keep working through everything is how we did it. So for the requirements for the test harness, we needed to be able to continuously test. And this came into fact based on our agile development of where as we would put in new functionality or either the requirements were originally made, we had to make sure that we continually tested them to make sure they were still being met and was not getting messed up with any new functionality added. Originally, this was supposed to be informal for testing of the requirements, but the independent test teams ended up liking it, and so we went through the formal qualification or the formal testing to checkbox the harness itself, and so now our formal independent people are using this to test some of the design level requirements as well. So it's already gotten recognition. It was for independence testing, so we would end up doing standalone software of where each person, when you're doing like the main propulsion system or the control algorithm or whatever, everyone is written in a little class, basically in C++, and so everything is modular. So everyone is standalone. You just have your publications and your subscriptions that you end up doing. You can also use this to test the functionality of certain routines inside. If you're trying to work on something specifically, let's say a functionality of a fault management or whatever, so we had to be able to provide that. It had to be configurable to many different uses, such as control algorithms or valves and all sorts of other different things. But we didn't want people to have to go in and recompile from scratch every single time. The inputs themselves, we had to make sure that they were maintainable. And so we ended up making sure that it was not a singular, like one person had to do it. It needed to be maintainable among different people, so we kind of abstracted that away. I'll get into that later. We wanted to make sure we could vary the scenarios through parameters of like configuration of the software itself, the phases during flight, and if we wanted to do any off-nominal testing for any just random stuff that you want to put in. And then ultimately, we needed to make it automated to continually test it as we were doing it earlier, because if it's done manually, people are going to forget or they're not going to want to do it. So to kind of go over the initial setup, we have a base class, which I consider kind of the harness infrastructure class. This is kind of the abstraction layer for the operating system. It provides a lot of our file input and output. It sets up the harness, such as just registering all the different tests among each other. This level, we will make the operating system calls and configurations. We provide some generic comparison utilities so that people can specify what they want to compare and how much tolerance and everything for floating point values versus integers and different things about that. It also provides general system emulation, so it kind of gives the overall, if you're trying to go through like a military 1553 bus, we have some generic libraries to kind of emulate that and put in through, but it's not the specific implementation because you did not want to be dependent on the actual one. The test harness setup. So then what we end up doing is we derive from the harness infrastructure. So every module that you're trying to create, you basically derive a class from that harness infrastructure class. This class is where the initialization of the software occurs. So you would set up your any configuration things, such as your parametric values or like persistence counts, times that you wanted, anything that's supposed to be kind of low level. You can set up a lot of the module specific support if you needed to set up structures or publications and everything, kind of global flags like that. The thing to note about this is that we wanted to keep it independent among each module. So each module class is independent and it's just getting called by a known base class or by the function in the known base class. It also provides the fault interpretation. So at this layer, we end up putting in like enumerations for if there are flags that we wanted, or when you have it from your configuration, so you can make a nice little enumeration that gets interpreted into a specific Boolean or a specific fault. You can set values of different things. You can set the length of time that the system needs to run or your tests need to run, but it continues on. So after that, each module then has another derived class, which is kind of its specific set of cases. And this has ended up getting, it starts to get a little bit more complicated here, but this is where you set up your specific support for a group of tests. So as we're going through, for instance, with the Guidance, Navigation, and Control, or GNC, they have a lot of history because they have a lot of filters and everything in their code. And so here would be where you could set up in their history values, since we did not want to have a lot of file I/O going through because the systems were never set up for that, running on the actual hardware. So this is where we put that in. We could subscribe to that, kind of the pre-calculate what it should see or what the inputs are going into, and then build up anything. It also provides the specifications of your comparison, so you can specify what variables you're going to look at and what's the tolerance and expected value range you're supposed to be into. So you have that. You can also specify any like output flags or any printouts. So if something fails, you can print out and say, here's printing out what has failed and how it's gone wrong. Then off of that, now we get to the specific test setup. So each one now has a specific test that gets called from the individual case class. So we have set it up so it's a comma-separated value set of inputs, And so that way you don't have to recompile. You can continually just update the CSV file that is loaded from the initial harness infrastructure and kind of go on with that. We also have, so the inputs, and since these are kind of all customizable based on the user, everyone can set up their own little things, but normally what ends up happening is you set up your specific inputs that you want, and then at the end of it, you have, here are all the outputs. This is kind of my expected output. So if you're looking for, is a flag set? Did we correctly detect that fault? Have we done anything with a specific flag? Are some of the intermediary values what I expected them to be? So you can set that up afterwards, and in the CSV, this is where it's read in and used for comparison. At this level also, you can specify what fault by just multiple ways. You can set up how, one way I did it was to set up a counter to say, I have a number of faults on this case, and at this time, I would change it to, let's say, 1, and then set the faults to whatever variable that I want through a specification layer. So you have all sorts of differences that way. So running the test cases. During compilation, we actually compile the full set of flight software. The reason being is that we wanted to make sure that it's always fully getting compiled and that the unit tests are staying in sync with the actual flight software itself. Because if not, you would have some of the unit tests that would just be old and they would say everything passes even though the actual flight software itself is not working. We have conditional compilation of the test modules based on a bunch of macros and pound defines to kind of determine what level you're trying to compile in. So if you're not looking at the main propulsion system, there's no point in compiling in those tests. So it helps for a smaller set, or if you know that there was a new release of some M and FM algorithm or anything that way, and you know they're all going to fail, there's no point in running it until those have been updated. We compile the software for the development unit, so we're actually running on what is supposed to be a complete representation of the hardware. It's not the actual flight computers, but this is what we had, so we were trying to make sure that we had as close to the actual architecture as possible, just in case for that there were different calculations based on floating point units and everything. The inputs are, as I said, are loaded via a CSV file, and all the comparisons are done that way as well. We ended up making it so that the outputs are simple pass-fail. Are you within the tolerance that you specified, or did you get your expected value? And what ends up happening is we go through and count up the number of passes and fails, so you can count out how many tests pass, how many fail, put up little warning printouts or whatever you want. But it also gives us a nice little summary report that we can then look back later at and say, hey, we've failed this many tests, where are they? The tests are run through a file specification as well, so what ends up happening is you have a list of what individual tests you're going to run. The reason for this is that if we have it compiled in for the module, the test module compiled in, but the test does not run, you get a notification saying that these tests were not run, so not to expect it to be working. So even if you've compiled everything in, but you only want to run through a specific set of tests, you can still do that. A lot of the automation of this has gotten built up because we were trying to look at a way to do this. And so the automation, we've ended up automating it through Perl and Python scripts, or I've done it through some Bash shell scripts. People have also used Jenkins for complete build things, and so we get nice little reports, and then some unfortunate person has to email those out and try and make sure that people fix those. But so the advantages / conclusions. The execution support was it was for multiple independent cases. That's what we were trying to keep up, so that you could specify whatever module or whatever set of cases you wanted. The developers have the ability to specifically and precisely specify what they're testing, so we have no requirements on, or no restrictions, I should say, on what they're specifically testing. So as you make your module, as you make your class, as you make your test, you can specify how in-depth you want to look at, as long as it's accessible to the harness. There's the ability to add automation multiple ways, because everyone has a different way that they want to look at it. So hopefully it can get expanded to other people or other tests. The harness itself can be executed continually, so we can put it through the build scripts if we wanted. We can run it weekly or daily is what we were down to. And if I remember correctly, we're up to about like 20,000 some odd tests, but that's continually changing. Granted, the majority of those are GNC because they end up doing a lot of filtered histories, and so we have to build it up. The approach can be adapted to others to support other projects. As I noted earlier, the CFS people seem to have a very similar approach to their UT assert. But that's really all I had. So should just be questions left.
Are there questions? Hold on, let me throw you a microphone. I'm going to throw up.
So do you consider these unit tests, or are they, do they test the integrated software? It sounds like you're compiling in your test, right, right into the software?
Yes.
And so they're testing one module at a time. Do you also have additional unit tests that you run prior, or this is it?
This is it. These are our unit tests. We don't do the integrated tests. We do that with a different system because it needs full feedback and everything. But yeah, these are just the unit tests.
And are your developers who write the code actually develop these tests as well at the same
Yes.
time or after?
Yes.
Yeah. Okay. Thanks. I'm Dan Rom I work at the Space and Missile Center here, and so in our program office, like for our future programs, we're looking for ways of having the contractors automate their software business. I guess not more like integrated testing of a full system. So I know you mentioned Jenkins, but is there any like commercial or open software package that could be done? Have you considered anything like that? It looks like you've really, this is more of a homegrown system, but that's what I'm looking for.
I can't really speak to that because I don't know. I had joined the project afterwards, and they didn't have enough money to support anything else outside, and so this is what I ended up coming up with.
Okay, thank you.
What language are you using for the flight software, and why did you choose it?
The flight software itself is C++. Why it was chosen, it was before my time. So, not because I'm young, but because I joined a little bit later, just to clarify.
So do you write test classes for testing base classes, or just like test module classes? Like if you run your test on a base class, it is supposed to pass the same test on a module class?
Yes, you could. I mean, there's no reason not to. I mean, most of it is straightforward. You can specify whatever you want to test it on. If you wanted to, and that was what I was trying to make sure that we could test it on the base class itself, all the way up to, well, you have one little function inside that you're trying to just mess with.
Just wondering if you considered having, in addition to this, maybe a Linux port, and maybe in addition that might help, doing faster development of, quick turnaround versus running on actual hardware all the time.
So the reason, okay, that's going to bring up a little bit longer of a discussion, but basically what it came down to was that since we're running on an ARM Power PC, the endianness is different and the floating point units are different. So you get different representations as well. And so what we're trying to do is make sure that everything would work as it is as close to the hardware as possible. Because as I have found out, our GNC people, they write all of their stuff on Linux implementation on an x86 64-bit machine. And what is ending up happening is we've branched a couple different ways because the Intel architecture actually has a 80-bit floating point register, so it's actually storing extra information, and that little difference can end up accumulating in a calculation, and all of a sudden you branch it a different way and say control an actuator to do something slightly different.
Okay. Any other question? Okay.
You mentioned for your test cases, your individual implementation of test cases, that there were CSV inputs and comparisons for how you specify the test. Where are those schemas kept, or how did you organize how the schemas were, implemented?
Basically, I mean, that is again based on, let me go back. It's at this level here, the test case class, the green. The users themselves can specify what order and what things represent. So at this level, for instance, instead of writing out true all the time, I made a enumeration that was just like T. And so you can put it in whatever order. A couple people have done it so you specify like the time that this event occurs at, and then some of the different inputs, and then you get your comparison outputs. But it's really left up to the user.
Okay. Thank you very much. Well done.